Today's topic is distance time graph. This topic includes in CIAE, IGCSE, GCSE, and O-Level Physics. This is me, Raza Kayani. In distance time graph, we are going to talk about how to plot the graph, how to label the x-axis and y-axis, and how to get the speed from the gradient. So I'm not alone in this lesson. I have Humpty Dumpty with me in this lesson, who is warming up. So I'll start with constant speed. Constant speed has three names basically. We say it a constant speed, uniform speed, or steady speed. If an object travels equal distances in equal time interval, then the graph will be a straight line. Body is moving with constant speed. As the object is moving in forward direction in a straight line, passing through the origin, so slope of the graph is positive. This is how can we know about the constant speed. If you see the graph is passing from the origin 0, 0, so this graph shows the speed is constant. How? In 1 second, distance traveled is 10 meters, if you see that here. In the next 1 second, the distance traveled is 10 meters. In further 1 second, distance traveled is 10 meters. So in every 1 second, the distance traveled is 10 meters. So in equal time interval, equal distances traveled. If this kind of the thing happened in the graph, when the time interval and distance traveled, they are same, then we say the speed is constant. So here, another reason to know about the constant speed, if I take this small triangle, the gradient of distance time graph gives the speed. So in this case, if I'll take this small triangle, so my gradient is the slope. If I take y over x, the gradient, if I take 10 divided by 1, so the speed is 10 meters per second in this case. If I take the gradient of the graph for this big triangle till 2 seconds, so in that case, it's 20 divided by 2, so my speed is again 10 meters per second. If I take this triangle, 30 divided by 3, and if I keep going further till here, if I take the whole this as a right angle triangle, and I take the gradient of that graph, so that will be 50 over 5, that is 10 meters per second. So when the slope is constant, basically the speed is constant. We are going to see further information about the distance time graph. An object will be stationary if it has a zero slope, if the gradient is 0. In this case, if you see that an object starts from here and travels some distance, and after that object is not moving, so that means the object is at rest. What we say that the object is stationary, at rest, it's not moving, because the slope of the graph is 0. There is no gradient here, it has a straight line. So straight line at rest, it could be here up, it could be here down. If we draw a straight line along x-axis, that also means the object is at rest. So distance time graph provides useful information about the motion of an object. The graph shows that time is going on, but the object is at rest after traveling a certain distance. If you see in this case here, after traveling certain distance, now object is at rest. We can see more explanation of stationary object after traveling 20-meter distance, this graph. That means the time is going on. We cannot stop the time, but object is at rest for something to open A car is waiting for the signal to turn green to start. So that is a stationary. Here, for 5 seconds, the object is stationary. If you see, there's no change in the distance is happening, but the time is going on. So that means the object is stationary. If we have a further line here, that also means the object is at rest after traveling a distance of 40 meters. Constant negative speed. Now, in the negative speed, the object is returning back to the same point, or the gradient of the graph is negative, basically. This is a case for the constant negative speed, where the object is returning back to the same point it started from. If the object started a journey from 0 meter, now it's going to go back again at 0. That means this is going in opposite direction. So in that case, we are going to take the speed as negative. Why for negative? The reason for the negative, if that's the speed, you know, the gradient of distance time graph gives the speed. So in that gradient, if I'm going to write y2 minus y1 over x2 minus x1. So this point is going to be x2 and y2, and that point is going to be x1 and y1. So in that case, here's a y2, here's a y1, because the object starts moving from here, from 50. So that's the y2, and here's a y1. If that my point is x2 and here is x1, in that case, my y2 is 0 in this case, and my y1 is 50. And my x2 is 5 and x1 is 0. So minus 50 over 5, that's going to give us minus 10 meters per second. So here is a negative velocity, means the object is moving in opposite direction. We can combine these above 3 graphs, the one I have mentioned, as a single graph. And what we can say in that graph then, how the graph will look like, for how long the object is going to be at rest, and how long it will take to return back. What can I say in this case? If the speed of the object is 10 meters per second, and if it's going forward in 5 seconds with that speed, and now on the road, it's at rest, basically waiting for 7 seconds. So after 7 seconds, what happened? The car is returning back to the same point. If here's the starting point of the car, and the car is returning back to the same point, it means its displacement is going to be 0. But if it travel a distance of 50 meters forward and the 50 meters backward, that means the distance is going to be 100 meters, but the displacement is going to be 0. So here's a combination of those 3 graphs. That shows 50 meters in the forward direction, a constant forward speed. That means it's at rest for 7 seconds. And that means it's returning back to the same point by traveling 50-meter distance back. So what I have mentioned, what happened by the combination of those about 3 graphs, like what will be the total distance? 50 plus 50 is 100 meters, but displacement is going to be 0 meters in that case. Now, we can conclude from the above graph, what is the gradient of the graph known as? What is the slope of the graph known as? So the gradient or the slope of the distance time graph is called speed. So here's a definition for the gradient. The gradient of the distance time graph is called speed. So basically, this part is going to give us a speed. And this part is also a gradient that's going to give us a speed. But here, nothing, speed is 0 because the object is at rest in that case. So we have a 0 meters per second in that case. So the gradient is given by the following relationship: change in distance over change in time. So distance always we denote along y-axis. So here is a distance along vertical axis, and here is a time along horizontal. So that's why if the graph doesn't start from 0, we can use this relationship y2 minus y1 over x2 minus x1. Or in other words, we can say that speed equals rise over run. So that's rise, and here's a run that way horizontally. So we can use that one also. So how much is rise over here? If I see the rise, if I take only speed from point A to B, so what is rise in that case is 50, and how much is run? That is 5. If I draw a line over here, that is 5 seconds. So my speed is 10 meters per second. So we can use delta D over T, change mean delta. So here we can use delta T over T over delta T, or we can use, in this case, we can use delta T over delta T to find the speed, or we can use rise over run to calculate the speed from the gradient of the graph, from the slope of the graph. Now we can practice one question. Iyad leaves home at 8 a.m. He cycles at a constant speed for 2 hours and covers a distance of 20 kilometers. He stopped for 4 hours at his workplace. From his work, he further cycles for 10 kilometers ahead and stops some. From his work, he further cycles for 10 kilometers ahead and drops some parcels to his client in 2 hours. He arrives back home at 6 p.m. with constant speed. Draw a distance time graph to show Iyad's journey. So Iyad leaves home at 8 a.m. (8 a.m.), 9, 10, 11, 12, 12 p.m., 1 p.m., 2 p.m., 3, 4, 5, and 6. Okay, we can label time along x-axis in hours, and we can label distance along y-axis in kilometers. So here we can label 5 kilometers, 10 kilometers, 15, 20, 25, 30, and 35. So in 2 hours, distance traveled is 20 kilometers with constant speed. So here will be a straight line. And then he stopped for 4 hours. So 1, 2, 3, 4. So for 4 hours, he's at rest. And then he traveled further 10 kilometers for a time of 2 hours. So 20 plus 10. So he traveled with constant speed further. And then what's happening? He returns back at 6 p.m. So he's returning back with constant speed. So that is the speed he comes back. So we can draw like, I don't have a ruler here. So with the ruler, we can draw a neat graph. So this is how we can draw the distance time graph for Iyad's journey in this question. We can practice some further questions. The diagram shows the distance time graph for a car, at which labeled point is the car moving with constant speed. So I have a 4-point over here, A, B, C, and D. So the question is, at which labeled point is the car moving with constant speed? So if I say, see here, A, it has a slope, B has no slope, C has no slope, D has a 0 slope. So the speed at B, C, and D is 0 because the object is at rest. So the only possibility of the constant speed is A. Why? The gradient of a distance time graph gives the speed, and the possibility is only A. Next question. Which distance time graph represents the motion of an object moving at a constant speed? We have again 4 options. A is not possible because this is not a constant. You know, that gradient is not a constant. Okay. Then B. B is the object is accelerating. It has no constant curve. So that's also not possible. C, that means the object is at rest. Straight line in distance time graph is at rest. But we have to know the constant speed. So only D is the possibility because the gradient of distance time graph gives the speed. So that slope is going to give the constant speed in this case only. Now we are going to see some further graph, not the straight line, the curving one, accelerating or getting faster. How can we know about the graph? The object is accelerating. So I'm going to see from here and decide about whether the object is accelerating or not. In 1 second, the distance traveled is 3 or 4 meters. In further 1 second, my distance is 6 meters. It's 11, 4, yeah, that's basically, it's 7, 6, or 7 meters. In the next second, the distance is 9 meters. In further 1 second, the distance traveled, that is 13 meters. And in the last second over here, the distance traveled, that is 17 meters. So in every single second, distance traveled is increasing. That means the object is getting faster and faster because it's traveling more and more distance in every single second, in every next second. So that's the reason we can say that such kind of the graph where the object is getting faster or the object is accelerating, not moving with constant speed. So we can see that here in this question, we can understand how can we relate with the constant speed and how can we relate a question with object that is accelerating or getting faster. So an object moves at a constant speed for some time, then begins to accelerate. Which distance time graph shows this motion? So what's the first case? An object moves at a constant speed first for some time, and then begins to accelerate. So we are going to see from these 4 options. Oh, that means the object is at rest and that shows the object is moving with constant speed. So constant speed, then begin to accelerate. So this is incorrect. That option is not correct. So we are going to see B. B, a constant speed, then at rest. So again, it's begin to accelerate. So that's not accelerating. First part is correct, but the second one is not matching with. So B is not the option here. If you see the part C, that part C shows the object is moving with constant speed, and now that's curving up. That is accelerating. So this is the answer, where object, the first part is moving with constant speed and then begin to accelerate. And that is curving up constantly, so that is not moving with constant speed basically. So this whole journey is accelerating. So we have a two-part. What is the first part? Constant and then accelerating. So C is the correct answer. Now decelerating or getting slower. We are going to see this one. Is the object moving with constant speed, slowing down, or getting faster? So I'm going to see in 1 second. In 1 second, my distance traveled is almost 18 meters. In the next second, distance moved is 12 meters. In further 1 second, distance moved is 9 meters. In further, that is going to move only 6 meters in 1 second. And finally, that is only 4 or 5 meters. So if we see that at every single second, the distance moved is decreasing, that means the object is decelerating or it's slowing down. Now we can combine these parts, okay, to decide about the distance time graph. So if I'm going to label this A, if this is B and C and D, we can see what's happening at A. A means the object is moving with constant speed. Now what is happening at B? At B, the object is at rest, stationary. What is happening at C? Moving with constant speed. Now, what's the difference between A and C? Okay, in A, the distance traveled 20 kilometers, 20 meters, for example, here's a meters. So 20 meters, that happened only in 4 seconds. But in C, the distance traveled was less than 4 seconds. So C, the object is moving a bit faster than A. Now, D means moving with constant speed in opposite direction. Moving with constant speed in opposite direction. Now we are going to see some further questions. The graph shows how the distance traveled by a vehicle changes with time. So we have A, B, C, and D options, and we are going to decide which one is correct. So what's happening between P and Q, Q to R, and R to S? A, P to Q, constant speed. Q to R, 0 speed. R to S, constant speed in opposite direction. So far, that is the option. And we are going to see what will happen. B constant, true. 0, that's right. Decelerating, no. It's a it's a constant gradient. So that's the basically It's not curving, it's a constant gradient. So that means constant speed. So this is not possibility, this part. Increasing, no, because it's not a constant gradient. Constant speed, no, because it is at rest. Decreasing, no way, because it's a constant speed there. Now, increasing, accelerating, no way. It's a zero, that's correct, Q to R. Decelerating, no, it's moving with constant speed. So if we see all four options, A is the answer, because P to Q moving with constant speed, Q to R, that's zero, at rest the speed is zero, and Q to R is a constant speed again. That's the end of the lesson. I'll see you next time with a new topic.